And as I mentioned yesterday, as a large manufacturer, as one of the premium leaders in the market, we're asking ourselves, why do we need to use blockchain, right? So it's really not about the technology, it's about the use case. And this is why I brought a use case with me today I would like to share with you guys. Because to me, this is a good example of how to move forward, how to assess a topic, how to take a deep dive to understand if it's really worth it to use the technology. So I actually brought a very nice presentation. I actually brought a very nice presentation. Unfortunately, it's in German, so I don't want to add more language complexity. So I'm just going to use the whiteboard. I hope that's okay for you guys. And I would like to start off describing the use case. And it's a very simple use case. So basically, it's something that applies to many large corporations that are spread throughout the world with a lot of legal entities in different countries, in different regions. And the legal entities, of course, do business with one another. So you can think of it this way. We have I'm just going to call it the holding as the overall entity on top of everything. And if you look at the regions, we have, for example, Asia, we have Europe, Middle East, and Africa. I'm just doing an example clustering, right? We have Americas, right? And so this is the overall structure of a company, right? And what happens is you will have a lot of legal entities doing business within a region, but also with a different region. And I'm just going to give them names. So basically, how does it work today? Say, for example, we have a plant in Asia that sells cars to a sales entity in the Americas. This is a case that happens a lot. For example, our commercial vehicles, some of them are produced in Asia and sold in South America, right? So even though we all belong to the same company, whenever we do business between different legal entities, between different countries and regions, of course we need to have a proper transaction as if it were a different company, right? So basically, if I want to sell something, let's maybe use a different color. Yeah, let's say I'm selling 100 trucks. I need to charge the face value of the trucks to entity E, of course. So what happens here is, yeah, let's say it's just a certain amount of euros the entity has to pay. And this is where it gets interesting, because we're talking different regions. So each region, of course, or each country has its own currency. The exchange rate between the currencies fluctuates. And so what we end up having is a very complex system of transactions. And we're just talking about one corporation, right? We're not talking about doing business with a completely separate entity. But the case here is A wants to sell 100 trucks to C, and C wants to sell them to the end customers. So far, so good. Now the question is, how do we settle the amount that is due for the trucks. And this is done in a very interesting way today, because first of all, we have a lot of business. So on your average day, you will have a very high amount of transactions between entities. So what could also happen is, on the same day, entity E is selling 50 vans to entity A. All right? And entity A, in return, has to pay the face value of the vehicles. So, of course, if you simplify this process, you could trigger a financial transaction for every single transaction we have here. So because we have a high amount, and because the cost of this transaction is high, because you always go through a clearinghouse, a third party, to settle, in this case, we have a system in place where we have a cutoff time each day, and then we have a look at the transactions. So in this case, we will not send the amount of money for the truck deal to A, and then A sends the amount of money for the vans back to E. We only want to work with a difference. So what we have in place is, in each region, we have a sort of hub to consolidate the amount of transactions we have. So basically, before we even trigger a real external transaction, we try to consolidate internally. And this means any business that happens within this hub is settled internally wherever possible. Each hub has its own currency. So for example, EMEA in euros, APAC could be yen. Yeah? And Americans, of course, US dollar. But then it gets very complex, because even in the Americas, you have a lot of currencies. So if you're in Mexico, for example, you're thinking peso. If you're in Canada, you're thinking Canadian dollar. And so it's very hard to come up with the final value, and you always end up having to settle externally. So this is the process as it is today. I try to simplify a little bit. So this is not the full detail. But at the end of the day, if I want to settle the debt E has towards A, I go through the settlement hub, and these guys settle with these guys, and they basically aggregate. So if I have a transaction here, and F has the opposite transaction from the other side, there will be no exchange, actually. So it's the same principle. You start aggregating to the top, and you really try to minimize the amount of transactions you actually have to place outside of your ecosystem, so to say. So this is how it works today. Now, if we look at a solution using blockchain, how could that help? Do you have any ideas? What's the pain point here? We're basically having to pay for each transaction, because if I leave my regional hub, or even if I leave my country, moving currency assets over regions is very expensive. Each country has its own rules, and at the end of the day, you're paying for each transaction, and that means we have the cost of transaction, right? At the same time, because this is a manual effort, it's supported by IT systems, of course, But you will have to do consolidation, and you will also have to create a clear audit trail, because later on we need to do reconciliation. We need to make sure that every transaction happened the way it should have happened. And this is, of course, as everything where humans come into place, errors can happen. People make mistakes. And this leads to even higher cost. So we're talking about efficiency. In this case, there's no real trust issue, because we're talking about wholly owned legal entities of the company. So I can trust one legal entity to behave in a fair way towards the other one. Yeah, we are all part of the same big family. So that's not an issue. Do we need a distributed database for this type of transaction? Probably not, right? So the key question is, why does it make sense? And this is how we're approaching this topic, right? So we're talking about a very high volume of transactions here, and also the face value of the transactions is very high. So we're not talking about thousands of dollars. We're talking about billions of dollars. And this is just one company. And now, why do I believe this use case is relevant for Hyperledger? Because we're not the only ones working this way. I mean, we're talking about an industry standard here, and the way this type of financial reconciliation is done. And so if we manage to find a more efficient solution, one that creates more transparency, and this is where the actual added value kicks in my opinion. Because blockchain will give you a very clear, concise audit trail. If there's money in the system, you will know where it came from and where it went at which time. And by design, you cannot trick the system, right? So how do we plan to actually solve this? We have a lot of complexity at the moment. We're talking of a lot of different currencies, and we're talking about moving financial assets from one country to another. So this is where the regulation kicks into place, right? There's a reason why we use banks the way we use them today. Yeah? Banks are there to help us bridge the gaps and to fulfill the regulatory requirements we have at the moment. So we're not talking about, a simple solution could be create a cryptocurrency, stop using real money, right? And just do all of your transactions on a private blockchain, yeah? And you're completely independent of any banks and of any clearing houses and any other third parties. So you would save a lot of money. If you're paying a commission for every transaction, we're talking about a huge amount of money. Now, that doesn't work today. And that is because we have to live with certain regulatory constraints. Meaning, if we move money from one country to another, we have to pay attention. Is the movement of capital free in the region, in the country we're talking about? Can I take money out of the country officially without having to register it somewhere or even to ask for permission from the regulatory bodies? Can I introduce capital into the country without any restrictions or controls? And this is really something that you basically have the whole array when it comes to countries. You have some countries that are very liberal, and you have some countries that are a little bit more restrictive in this regard. And if we look at the landscape today, my personal opinion is having a cryptocurrency is a challenge. It is a challenge because it introduces a new vector of risk into the equation. So you're saving money, you're saving cost of transaction. At the same time, you're moving in a field where there's no clear legislation at the moment. So what can we actually do today? In this case, we're talking about changing the system, changing the way we work in this process. And what we're going to do as a starter is we're going to focus on the European Union, on the Eurozone, for a very simple reason. We have one currency in there, so we don't have the currencies as a factor of complexity. And we have one consistent legal framework, which also means I have to fulfill the requirements of one regulator and not 10 or 50 or 100. And I can also reach out to this regulator and find out what are the limits of today's rules. How far can I go? Where do I have to stop? Where do we need to start a discussion in terms of reshaping the rules, expanding them exactly to help us cover this type of use case? So what does that mean? What we would like to do is stick to Europe, stick to the Eurozone. This is not part of the presentation. But yeah, so basically that means we want to take the organization we have at the moment away from the system. So basically, we would like to have a flat organization where we don't need to have any more hubs to consolidate. So basically, we want a peer-to-peer communication between the legal entities in order to settle any debt. And at the same time, because these guys can talk to each other through a common platform, we want to actually settle debt, settle open positions internally for companies within Europe. This is something we're talking about. This is something we're evaluating at the moment. It's not a project, so please don't quote me on this. Yeah, I just want to share something we're working on. Yeah, and that means in the coming months, what we want to do is we want to have a look at this use case. We want to propose a technical solution for it. And we want to really gain a deeper understanding, because it's not about the technology, it's about the added value for your use case. And so if we find a way of implementing this type of transaction using a blockchain, and if we actually find the right legal framework for it, this is something we can actually do. And it's not something that applies to Daimler only. If you look at any large corporation, the amount of business that just happens within the legal entities of the corporation is so high. Yeah? Everyone is paying a huge amount of money as of today just to cover internal transactions. So we saw the process of importing and exporting, I think it was shoes a while ago, right? So that's for doing business with a different party. Now imagine you have to go through the same effort to do it just within your own family. Yeah, we're really talking about a lot of money. So my question to you, and this is something where I hope we can start a discussion. Yeah? If we look at this type of issue, we basically have a couple of challenges. We need to bridge the gap between proper fiat money and cryptocurrencies, because at the end of the day, if we're talking about today, your bills, your receipts, your debt is going to have a face value in euro or dollar or yen or some other fiat currency. Yeah, I mean, realistically speaking, Bitcoin you can use for certain cases, but if we're talking B2B, we need to stick to hard currencies that have a certain intrinsic value with them. And that means we need to find a way of really translating the face value of a transaction into a cryptocurrency. Now, of course, the easy way to do this would be create an exchange, right? Your legal entities pay euros into the exchange. They get the cryptocurrency in return. You could do ICOs, but it's all just ideas. So the actual way we solve this problem is still open. And this is something I brought this use case with me today because this is something where we would like to work with the community together. So not just today, but in the upcoming months, we would like to see what we can do as a community in order to find a solution to the key issues we have in here. And in return, the solution to this type of problem can be given back to the community. Because at the end of the day, we're talking financial transactions, and that is not our core business, of course. Yeah. So if we're talking about increasing efficiency, this is in the interest of the community, and this is exactly where the thought of sharing, of creating open source, really makes sense, in my opinion. Yeah, we all gain from it, and it really benefits the right parties. For you as developers, as enthusiasts, it's also a good way of really finding the way of understanding what type of use case does actually make sense. Yeah, I mean, what I showed you guys before, this is really the initial stage of a very long discussion we're going to have. So nothing is set in stone. I could not tell you the concrete solution to this topic. I cannot even tell you if we really do need a blockchain at the end of the day. Yeah? But as long as you actually manage to create a clear advantage out of it, I think it's worth it. Yeah? So it's not just about trust. It's not just about anonymity. It's not just about having a digital asset somewhere, be it a currency or something else. The question to me is, if I build a classical system, will I be faster? I don't know. Will it be cheaper for me to build, to maintain? I also don't know. So at the end of the day, in my opinion, if you look at a use case and you realize you might not be using the full potential of the technology, as long as you gain a clear benefit out of it, it's perfectly okay. In this case, if we actually manage to move towards a cryptocurrency, it's a perfect usage for blockchain. If we manage to solve the regulatory constraints and actually can move away from using a banking system to settle internal transactions and towards a crypto system where we can just do it P2P without any intermediary, without paying any commission, that's a real efficiency in there. Do you have any questions so far? See a lot of confused faces.
Maybe there could be your internal, say not banks, but financial companies that have some free money or some proper money, and they have a license to transact, and without leaving actually the financial.
Mm-hmm. Yeah, but this is exactly how it is today. So basically, if we look at the other picture again, if you're settling internally here, you're not actually using money. It's just a number on an account. But if you have to settle with a different country or with a different region, this guy will actually transfer money to the central hub. The central hub will have to transfer money to the other central hub, and they might have to do a currency exchange. So that's already the first point of inefficiency. And then this guy has to transfer money to this guy. And it could also be that they have a different currency.
Do you have hubs per country?
No, it's per region.
Per region. So you have some money transfer or currency transfer inside the region.
Yeah. So basically the idea is to consolidate within the region first. And if you really need to cross the borders of one hub, it's only for the difference amount. It's kind of like the way the banks work too, right?
Do you consolidate like full transactions, like single transactions, or you consolidate all transactions inside of one country and then
It's let's do an example. So basically, I owe this guy, I don't know, 10 euros. Yeah, let's keep easy numbers, okay? So this guy owes him 5 euros. Okay? And we reached the cutoff time. So basically, what do we have after consolidation? This guy owes him 5 euros. Yeah? Now, if we move towards another hub, it gets more interesting. Because here, I might be able, if we're in the same country, if we're in the same region, and if we're in the same currency, it's easier. If I owe him 5 euros, but this guy uses, I don't know, if this guy uses dollars for whatever reason, I can't actually transfer 5 euros. So what I will do is I will send 5 euros here, and this guy will try to settle the amount in dollars based on free cash flow they have here from other transactions. And if they cannot, that will trigger a currency exchange, that will trigger, you know? Now, if we're moving to a different region, it's the same principle. So let's say 100 trucks, 100 euros, yeah? 50 vans, $50, yeah? Very cheap. It's not going to happen in reality, but just to keep the example easy. So E owes A 100 euros. So E would basically contact its hub, but E uses dollars. So E will have to send the amount in dollars, right? And the hub will transfer to the other hub, and they will settle here. If the two hubs, just the way we had this example, it also works for the hubs. So the hub will look at the total amount it owes the other hub, and the other way around. And the total will always be the difference, keeping into account the different currencies. So you will have the difference in each currency, and that's the money you actually have to transfer to settle. Everything else, it could be, for example, you have 1 million here, and this guy, yeah, I owe him 1 million, and he owes me 99,000, just 9999. At the end of the day, it's basically, it's just going to transfer one. Yeah? Per day. It's at the end of the day, because certain countries also expect you to settle at a certain time period. So you have a cutoff time, think 6 p.m. or something like that, and that's when the consolidation kicks in. Whatever happens during the day, you just put it into an account. So it's basically like a sort of a ledger. I owe this guy this amount of money. He owes me this amount of money as a list. At the end of the day, they look at the whole list and try to find out what's the real obligation you have towards a different entity.
So that couldn't be done just once per month. Like you will have a more efficient system if you can do that one a month.
The problem is we're talking about very high amounts of money here. So it could happen if you do it once a month and you are one of the legal entities that's selling, it will have a huge number on its books that's unsettled. So for example, if you run a business and you're selling me, I don't know, let's say you're selling me tires, yeah? And I place an order for 1 million tires, and I tell you we're going to settle at the end of the month because I sell apples and you might buy some apples from me.
Yeah, we're talking about one organization. So all mine like one organization.
But it's not, so the way accounts work is there's no central account. So you will have in each country, for each legal entity, you will have an account, right? So from this guy's point of view, he doesn't care how much money the total organization has. He only cares whether he has a cash flow problem or not. If my account is empty and I don't get any money back, I need to get money somewhere else. So I will have to go to a bank, get a loan, and pay interest on it. And that's the reason. If you're moving a high amount of money from A to B, you want to settle as soon as possible. We do it once a day today because it's the way the process works at the moment. You could also have it real time if you had the actual cost of transaction that was lower. It makes sense once a day because you save a lot of fees for sending and receiving money.
So the main problem here is conversion of currency.
Yeah. And of course, one of the objectives is always to keep the books clean, right? And that means if I'm the CFO of company A, I want to know how much money I have. I want to know how full is my wallet, and I'm not talking about the credit card, I'm talking about the cash. How much money can I spend without having to get a credit for it, without having to get a loan for it? So doing it once a day gives me at least the average of the day. It might be that I have to take a credit for a couple of hours, but it's way better than having to pay interest over a whole month. Yeah, I mean, we're talking billions of euros here. We're not just talking small numbers. And especially for manufacturers, you will experience this issue very often because the manufacturing business is a very cash flow intensive business. You're spending a lot of money on material. You have a lot of material in your production halls. The actual product is worth a lot of money. The face value of the product is high, and you keep that in your books until you actually sell it. So for some markets, it's better. For some other markets, for example, if you're talking automobiles in Western Europe, if you order a car, you actually go configure the car, order it, and then the car factory gets the order and they build the car for you. If you look at the States, for example, it's different. You walk into a dealer, You point at the car you want to have, you pay, you take the keys, and you drive away. So in the US, for example, the dealers will have a lot of money sitting on their shop floors. And this means if you're basically binding a lot of money, yeah, the amount of transactions goes up automatically. So at the end of the day, it could be we have transactions from A to B and back worth millions, and it doesn't have any impact on the actual profits of the company as a whole. Because, for example, if you lend money to your father, your family as a whole still has the same amount of money, right? Nothing has changed. If you give money to your sister, same deal. So the cash flow magnitude is way higher than the actual business that a manufacturer does. So if we're talking about paying fees, we're talking about a lot of money. I cannot give you any specific numbers because I don't know them. And even if I did, well, yeah. But but this is the main reason. So what I would like to do in the coming weeks and months is really getting a discussion, share with you guys how we're tackling this issue. And it might very well be that we decide to go in a different direction at the end, because it's not about using blockchain, it's about solving the pain points. Any further questions?
In Eurozone, it's maybe more easier to have a e-currency, euro backed by a European bank. So then every business in European zone can be built very fast, with low cost, and then the nation banks can have their own upper currency to move. Right? So we just need a technology that finds identity accounts and privacy. But we don't need that privacy in a corporate wise, because corporate entities can see the balance of other entity. It's not a big deal, but in a big way, global we need privacy and the identity together.
Mm-hmm. And I mean, at the end of the day, the way the system works, it's not limited to one organization, right? So we are talking about the Eurozone here because it's large enough to have enough businesses in there, both within and outside the organization. And this is step one, right? So the real advantage, the real efficiency gain comes in when you're talking about settling accounts with external partners. This is when the real value kicks in. So a lot of potential, a lot of risk at the same time, because you would be completely bypassing banks. And if you think of settling with external parties and actually combining this with a smart contract where you say, I ordered something, and when I get it, I will confirm I got it. So when the sender confirms he sent it and the receiver confirms they received it, that triggers the payout automatically. This would really be the big step, the leap, so to say. But we need to start somewhere. Any further questions? Okay, thank you. If you would like to ask later, just.
Workshops and a panel discussion with speakers.
Yeah. Yeah. But problem is question for the carbon capture company. It's like financial task. Is it for everyone? And then like, there's a possibility to solve this problem on a like people level, one level. Yeah, but then again, the question remains: how do you do it exactly? If you use a cryptocurrency, you need to render it. You know, it's one thing to do it as a small entity or as an individual. But as a large corporation, you have
Данный проект представляет из себя систему электронного голосования между стокхолдерами, то есть держателями акций. Как, может быть, некоторые из вас знают, значит, все акции, по крайней мере в Российской Федерации, подлежат обязательной регистрации в центральном депозитарии. Далее, значит, вот эти вот акции, которые принадлежат какой-то компании, они распределяются между так называемыми номинальными держателями. Номинальные держатели акций – это организации, юридические лица, которые производят с ними различные операции, торгуют, продают, ну, по сути дела, брокеры. Как бы сами по себе акции, они принадлежат как организациям, так и физическим лицам. При этом, значит, строится достаточно сложная цепочка между номинальными держателями. В основном это дерево, но иногда может представлять из себя граф с различными циклами, ветвлением и прочим. Данный проект является платформой для электронного голосования. Давайте перейдем к слайдам. Так. Нет? Да, у нас присутствует PBFT. Вот. И большая часть бизнес-логики, конкретно проверок валидности операции, она была внесена в чейн-коды. Вот, собственно, здесь очень большая диаграмма, которая описывает всю нашу систему. То есть номинальная нода регистратора. Соответственно, регистратор в нашей ситуации это определенная роль. Роль, грубо говоря, того, кто создает голосование. И множество нод номинальных держателей. Все эти ноды объединены в одну общую сеть. В качестве стартовой точки у нас существует некий корневой чейн-код, который деплоится вместе со всей сетью. И этот чейн-код изначально содержит как бы ключи регистратора. Это, соответственно, публичные ключи для шифрования данных и публичные ключи для цифровой подписи. В дальнейшем значит, туда вносятся номинальные держатели. Это так называемый off-chain процесс, то есть, грубо говоря, каким-то способом, e-mail, там, флешкой или там фельдъегерской почтой какой-то приносится публичный ключ значит, ноды номинального держателя, и этот ключ вносится в корневой чейн-код, и в дальнейшем данная нода как бы распознается по этой цифровой подписи. В качестве, значит, всего приложения там у нас используется набор докер-контейнеров. То есть докер-контейнер для сервисной части, собственно, сам фабрик находится внутри докер-контейнера. И, соответственно, как бы у нас есть некие сторонние сервисы для подтверждения того, что наши операции являются валидными. Можно следующий? Вот. В качестве подтверждения этих действий мы используем так называемые Zero Knowledge Proof. Значит, Zero Knowledge Proof позволяют нам сделать математическое доказательство с помощью эллиптических кривых, что перевод, грубо говоря, там, денег, голосов, единиц измерения с одного приватного кошелька, на другой является валидным. И то, что значит, сумма, списанная с одного кошелька и перечисленная на другой кошелек, совпадают. И то, что, соответственно, как бы хозяин кошелька, с которого списывается валюта, имеет приватный ключ или доступ к этому кошельку. Как у нас развертывается само голосование? Первая фаза – это эмиссия. Значит, эмиссия здесь не имеет никакого отношения ни к майнингу, ни к чему подобному. То есть это Zero Knowledge транзакция, которая начисляет определенное количество денег на изначальный кошелек. Emission wallet. Соответственно, как только у нас случилось голосование, о нем оповестили всех, при создании вот такой вот транзакции, которая по сути перевод с одного кошелька на другой, как бы первый кошелек у нас получается, что он берется ниоткуда, из воздуха. Изначальное количество акций у нас известно, соответственно, как бы приватный ключик для расшифровки того кошелька, который, грубо говоря, из воздуха берется, мы распространяем между участниками голосования с помощью их ключей криптографии. А дальше, значит, происходит начисление голосов. Голоса у нас начисляются уже на конечные кошельки владельцев акций. Соответственно, такие действия, они валидируются всей сетью. И то, что там определенный человек получил N голосов, это все видно. То есть как бы голоса в его кошелек как бы пришли не из ниоткуда, они пришли из emission кошелька в кошелек Output. А после этого происходит голосование. На самом деле вот здесь вот как бы надо было, конечно, изобразить не один кошелек, а несколько. То есть вы понимаете, что есть вопрос, как бы есть несколько вариантов ответов. То есть по сути держатель акций голосует своими голосами на определенный ответ. И все это сопровождается генерацией так называемых Zero Knowledge Proof'ов, которые подтверждают, что да, проголосовал именно этот человек и проголосовал именно за эту опцию. Вот. Но сколько, значит, грубо говоря, голосов он туда отправил, соответственно, как бы никому не известно, кроме самого умера и держателя вот этого кошелька. Поскольку вот этот вот кошелек, он уже принадлежит не регистратору, не участникам сети, а принадлежит специальной роли счетной комиссии. Дальше счетная комиссия получает некоторое количество записей в этом кошельке. То есть каждый голос как бы это отдельная запись, отдельная транзакция. После этого происходит агрегация. Агрегация это сложение двух пришедших транзакций в одну. Значит, соответственно, как бы у нас счетная комиссия считает эти голоса, каждый раз генерируя Zero Knowledge Proof на подсчет. В результате все могут убедиться, что голоса посчитаны верно. А после этого, значит, поскольку значит, вот эти вот голоса, они были закриптованы публичным ключом счетной комиссии, и счетная комиссия не имеет права публиковать свой приватный ключ, чтобы убедиться, сколько конкретно там голосов, она переводит это на публичный кошелек результатов. Тоже, соответственно, как бы происходит агрегация, происходит паблишинг, и, соответственно, это все сопровождается пруфом, и уже конечный ключ приватный от кошельков результатов распространяется между участниками голосования. Собственно, вот так вот организована платформа. Можно следующий? Да, ну здесь как бы перечислены типы транзакций, которые мы используем в нашей системе. То есть 1 к 1 это для, соответственно, совершения волеизъявления, то есть для голосования, либо для эмиссии изначальной, когда мы из воздуха генерируем монетки. Вот, либо для публикации голосов, то есть когда мы с конечного кошелька ответов переводим это все на публичный кошелек. Значит, для распределения голосов между пользователями, соответственно, как бы транзакция 1. Вот, тут единица, двойка, как вы понимаете, это количество входов как бы, и количество выходов от данной транзакции. Ну и 2 к 1 это калькуляция. Вот следующий. Вот, собственно, как вы понимаете, не только голоса мы публикуем внутри нашего блокчейна. Hyperledger позволяет в своей Key-Value-DB организовать нечто подобное таблицам. Таблицам базы данных. Соответственно, как это было реализовано в нашей платформе. Мы завели прототаблицы, то есть у нас появились такие сущности, как namespace. Вот. Namespace это, соответственно, голоса держателей, это, к примеру, повестка голосования, что тоже вносится в блокчейн. И, соответственно, как бы там вопросы, варианты ответов, кошельки значит, ответов, кошельки результирующие. В качестве ключа, то есть как бы в качестве ключа как бы имени таблицы мы используем пару namespace и ключ. И, соответственно, некоторые такие служебные значения, как, собственно, тип, того, что мы положили в эту таблицу, значение в формате JSON и, соответственно, имя той ноды, которая произвела запись. Значит, для чего все это было сделано? Кроме вот этих вот замечательных Zero Knowledge Proof'ов, которые мы реализуем, реализована дополнительная бизнес-логика на тему того, что кто, какая нода и какая роль имеет право на совершение различных действий. То есть как бы к нашим таблицам, нашим namespace. Namespace это по сути у нас сущность. То есть привязана некая политика ограничений, политика permission. Ну, в общем-то, что можно сказать, что, например, голосование, то есть повестку голосования, может создать только нода регистратора. И, соответственно, как бы какие-либо изменения над этой сущностью может сделать тоже только нода регистратора, имея собственную там цифровую подпись и имея собственные там ключи. Соответственно, кошелек конечного держателя может создать только нода, которой этот держатель принадлежит. Изменения на этот кошелек могут производить либо номинальный держатель, либо регистратор, поскольку регистратор начисляет голоса. Вот на основании вот таких структур данных реализованы наши чейн-коды, реализована бизнес-логика и различные проверки. Можно дальше. Собственно, как у нас организована архитектура самих вот этих вот смарт-контрактов чейн-кодов. У нас есть пира на каждом номинальном держателе и регистраторе. Есть набор чейн-кодов, то есть это корневой чейн-код и отдельный чейн-код, который обслуживает данное конкретное голосование. Для различных событий, то есть там, например, оповещение о голосовании, там, процедура раскрытия и прочего, у нас используется ActiveMQ. К сожалению, значит, модель событий версии 0.6 не была реализована для Java API, и поэтому, собственно, пришлось из внутри чейн-кода дергать отсылку в ActiveMQ. И, соответственно, наш замечательный Snark-сервис, который занимается генерацией и проверкой вот этих вот Zero Knowledge Proof'ов. Дальше. Что у нас планируется? На данном этапе мы закончили фазу прототипирования. И впоследствии мы планируем следующую фазу, это переход уже в продакшн. Соответственно, какие мы можем сделать улучшения для нашей системы? В первую очередь, это миграция на версию 1.0. Поскольку, на мой взгляд, она more production ready. Соответственно, версия 1.0 позволяет нам достигать такого результата, что мы управляем деплоем вот этого смарт-контракта на определенных узлах. Таким образом, мы сможем достичь того, что только участники голосования будут поднимать эти контейнеры со смарт-контрактом, обслуживающим это голосование. Остальные же будут получать слепки данных и доверяя уже участникам голосования вносить их в свою реплику. Дальше что у нас еще планируется? Значит, эмиссия в нашем случае в фазе прототипирования происходит от регистратора на конечные кошельки владельцев. Это довольно ресурсоемкая процедура, поскольку, значит, генерация любого пруфа, она занимает в системе порядка 40 секунд. Соответственно, мы собираемся перепоручить эту роль уже нодам номинальных держателей, чтобы они, получив общую сумму голосов на своем, грубо говоря, избирательном участке, уже распределяли эти голоса между своими, соответственно, вкладчиками. Вот, соответственно, точно так же можно организовать агрегацию голосов уже на нодах. И что мы еще хотим сделать, это мы хотим именно вот этот вот алгоритм Zero Knowledge Proof'ов внести в консенсус. Каким образом это будет сделано, пока вопрос. И пока это тема для обсуждения. Дальше. Ну, собственно, уроки, которые мы вынесли из этого проекта. Здесь замечательная цитата из фильма «Касабланка». И замечательная картинка книжечки Аурелии. Собственно, получилось у нас то, что в проекте было использовано большое количество технологий, большое количество языков. Это чистый C, это Go, это Java, это различные shell-скрипты. И, собственно, получилось у нас не очень красивое животное. В дальнейшем, конечно, мы планируем некоторые вещи выбросить, некоторые вещи как бы заменить. И довольно большую часть как бы вот таких вот избавлений от лишних технологий нам предоставит, надеюсь, как бы переход на версию 1.0. Ну и естественно, что докер это не панацея. То есть проблемы с деплоем все равно присутствуют. Собственно, наверное, на этом у меня все. Пожалуйста, вопросы.
Да, можно просто вернуться на слайд?
Можно, конечно.
Ладно.
Сейчас мы попробуем. Одну секундочку. Нет, свернемся обязательно.
Там только, ну вот я не понял, почему только два варианта, два кошелька для
Кошелька для воутинга.
да.
Сейчас, секундочку. Сюда. Назад.
Там кошелек, он
Вот. Да.
он все варианты голосов принимает, или там
Нет, конечно, это чисто схематическая картинка. На самом деле, понимаете, дело в том, что, смотрите, вот у нас, грубо говоря, происходит эмиссия. Эмиссия происходит из воздуха в определенный кошелек, на самом деле, это таблица. Значит, сколько вопросов, сколько кошельков. Ну, там зависит от вариантов. То есть там есть некоторые варианты, что там какие-то акции не могут голосовать за какие-то вопросы, какие-то могут голосовать. Соответственно, сколько вопросов, сколько кошельков будет. Значит, после этого идет начисление, когда идет начисление голосов.
правильно, что каждому голосующему дается по одному голосу на каждый вариант.
По одному количеству голосов на каждый вариант, да, абсолютно верно. Вот. Соответственно, это количество голосов, это количество акций у него на руках.
А потом он переводит в тип или все типы, вот, есть там 10 вариантов, за что голосовать, он только один тип переводит на какой-то кошелек.
Да, естественно, как бы там все вот эти вот группы кошельков, они, естественно, разграничены логически.
Просто там даже не зная, что именно и сколько там было переведено, понятно, за какой вариант.
Не совсем так, на самом деле. Дело в том, что я не описывал как бы немножко этот процесс. На самом деле, реально у человека, то есть, например, у нас есть 4 варианта ответа. Соответственно, здесь у нас 4 варианта. Ну, вернее, как бы 4 кошелька. На каждый вариант ответа по одному. Но при этом регистратор, когда вычисляет голоса, он на один кошелек зачисляет, грубо говоря, 1, 100, там, 5, 10 голосов, а на остальные начисляет единицы. То есть при этом, когда происходит голосование, пользователь голосуют, например, как бы первым нулевым кошельком за первый, вторым за второй, то есть это рандом происходит. И, естественно, как бы вы не видите количество монет в новом кошельке. Вы видите только факт перевода. Факт перевода денег с одного кошелька в другой, и то, что этот перевод является верным. Вот. Таким образом, даже зная, что, там, например, пользователь второй, там, первый, третий, как проголосовали за какой-то вариант, вы не знаете, сколько туда будет. Голосование реально тайное. Вы не сможете увидеть результаты заранее.
Ну, обычно там голосуют всеми своими.
Да, конечно, вы голосуете всеми своими акциями за какой-то вариант с одного кошелька. Вы знаете, что вот на этом кошельке у вас есть акции, поскольку вы являетесь владельцем. А на остальных у вас нули. Соответственно, за остальные варианты.
А почему у нас всех нули?
Потому что вам начислили при разделении голосов. Вот никто не знал.
Ну, регистратор знает.
Регистратор знает, да.
Ну, получается, ну, это уже точка отказ, если регистратор хочет какое-то свое решение, то здесь он, ну, или он, по крайней мере, может заспойлерить, он может рассказать другим.
А вот это уже лежит немножко в другой плоскости, называется плоскость уголовного. Да, конечно, никто не застрахован от того,
Ну, это как бы и сейчас такое есть, но от этого никто не снимает решение.
собственно, да. Вот, но на самом деле, смотрите, вот у нас, говоря, произошла эмиссия, произошло голосование, а дальше уже как бы в принципе, как всегда, об этом знает регистратор, например, он может отследить, что этот человек там голосовал. Вот, но на самом деле регистратор, как бы, в принципе, будет знать, что знает он сам.
Просто если бы, например, всем одинаковое количество, ну там, грубо говоря, каждому держателю акций по его доле выделяли там токен, ну, что угодно. И он потом мог проголосовать, ему голосовал за все варианты, но просто он отправлял неизвестную сумму на каждый вариант. И там, где больше, там и было бы, а вот эту сумму неизвестно, правильно? Если бы он отправлял на все варианты какую-то сумму, а потом...
В принципе, да, это тоже хороший вариант. Делать в кошелька мира транзакцию типа 1 к 2, при этом как бы остаток отчитывать на свой кошелек, значит, какое-то количество переводить на кошелек результата. Это тоже как вариант рассматривается. Да, конечно.
Три вопроса.
Да.
Первое, вы использовали да?
Консенсус говорит по БС, да.
Почему не забывали использовать университет, как в этой задаче, у каждого участника не стоит цель противоречия?
А вы знаете, на самом деле в шестерке просто я, честно говоря, кроме ППС никакого другого человечества не знаю, да. Там есть УЦ еще, на самом деле, который как, ну, является отсутствием концепта.
Второй вопрос. Как происходит актуализация данных о количестве акций? Потому что между различными городскими голосованиями могло измениться распределение. Как это решается? Данные берутся с внешней системы, то есть какая-то система подобная раковому?
Смотрите, дело в том, что когда я говорил о распределении, об оповещении о каскаде, там на самом деле каскад идет в две стороны. То есть первая сторона это то, что регистратор, например, знает ноды своего первого уровня. Ноды первого уровня знают ноды второго уровня, и при этом они знают количество акций, которые у них есть. Вот. После этого я на самом деле не дорассказал, конечно, о каскадном раскрытие у нас происходит по обратному каскаду. То есть нода номинального держателя уже конечная. Она создает кошельки для своих оунеров. Вот. И после этого она отправляет наверх запрос с данными этого оунера и количеством акций, которые у него есть. Вот это уже происходит раскрытие наверх.
Есть вопрос по поводу реализованной приемной. То есть это двухуровневая система, да? На первом этапе принимается решение о том, какой вопрос вынести на голосование. А вторым уровнем уже голосуется за этот вопрос, именно это позитивное решение на первом уровне. Ну, то есть решение принимать о том, вообще какой-то вопрос ставить на голосование, или нет, будет реализовано, планируется.
Ну, пока такого вроде как у нас не было, да, ну...
Централизованно решается набор вопросов, да, которые задают.
Говорите, что создатели выбрали Hyperledger, чем сравниваете, что выбирали?
Ну, вы знаете, это на самом деле просто первое, что на ум пришло. Потому что вроде как платформа есть, и ранний выбор на платформу занимался.
Вначале рассматривали Пинком.
Пинком, да, рассматривали. Но я думаю, что на этот вопрос, наверное, Денис Баранов ответил, но его заранее
Примеры пользователей интерфейса есть, посмотреть, как оно выглядит.
Ну, приходите как бы на этаж ниже, я запущу, покажу. Вот. Но, к сожалению, как бы пользовательский интерфейс в данной ситуации это не столь интересно. Потому что, ну, вы понимаете, мы ограничились некими на фазе тестирования, мы ограничились некими техническими формами. Я могу показать, как это запускается, как могу провести там небольшую экскурсию. Потому что не хотят управлять. Ну, я так понял, что вопросов больше нету. Ну, пошли купаться.
The other room.
I think there's networking, so we would be.
Oh, okay.
I've announced it.
Okay, great. Yeah, anytime is fine. And
Okay.
how long should I talk? Oh.
Have you planned over now?
Sleep. Yeah. Mental sleep.
Okay. So we are ready to begin now. Yes. Yes. Okay. Welcome, Makoto.
Maybe
Okay. Very simply, welcome, please.
Okay, this works. Okay, I hate using a microphone, but I guess there's no choice. So yesterday I talked a little bit about just a brief overview about Hyperledger Iroha and some of the things we're doing with it. So today I want to talk more about some of the details about our core model and data structures, and from that I want to kind of hopefully get some questions from people and go into more of an interaction. So it'd be nice to be as interactive as possible, so I don't have to do all the talking. And also, I would like to discuss possible use cases for things like interledger transactions. Like, what are some of the use cases? So if you had interledger transactions between Iroha and, say, Fabric, what are some of the use cases you would want? But so before I talk about interledger and possible use cases, it's useful to understand Iroha more from a system. So what I'll do is I'll talk about some of the data structures we have, and then from there I'll try to talk a little bit about maybe I guess some of the differences between Iroha and Fabric and Sawtooth. So the main platforms in Hyperledger, and maybe when you can use some of these different ones. Okay, great. So let's get started, and hopefully my my computer won't die. My adapter is not so good, but it seems to work right now. Okay, so the main resources for Iroha are on Hyperledger, on GitHub. So if you go to GitHub and go to GitHub/Hyperledger, you can search for Iroha, and you get maybe these different projects. So there's iOS, Android, etc. These iOS projects here are really just SDKs to help create things like key pairs. So like, for example, you can import Iroha Swift, and you can create a new key pair. We use SHA-3 and also Twisted Edwards curve, so ED25519 for our cryptography. So you can generate a key pair and then use that key pair to cryptographically sign some message like this, just as a string, and you get a signature. And you can also verify the verified cryptographic signature using the public key. And you can also have access to the various SHA-3 hash functions. So this is for iOS. Then we've got Android, of course, JavaScript, and Python, and Scala, and also .NET. So these are just easy ways to generate keys and do cryptographic signatures on the device. In the future, we want to expand this SDK to also help you generate proper transactions, so Iroha transactions, using our core transaction model. But right now, it's really just for cryptographic primitives. And why is this important? Well, it may not be obvious, but even when using the same algorithm, so SHA-3 and Twisted Edwards curve, in Java or Swift or C++, the libraries that are available give slightly different output. So they append new lines. They maybe encode things in a different base. So it's really hard to compare the output together. So if you have an Android phone and an iPhone, you should be able to cryptographically sign a message using the same keys and get exactly the same output. But that's really hard to do because maybe these libraries give slightly different outputs. So we spent a few months working on getting these libraries to all give the exact same output for the same input. So that's one of the contributions that we have. All these are licensed under Apache 2, so feel free to steal this code and do anything you want with it. So IDRHA itself, you don't want to look at master because it's kind of old and doesn't really match our vision. But the latest branch that is kind of interesting to look at is of course develop, and so you can look at develop, and this is what we're working towards. Maybe what's interesting to look at is our data model or schema. We have various proto files. So what we use to encode our data model is our protobuf files, and then we have a kind of a DAO, that a data access object that kind of sits between these files and the actual the files and the actual kind of objects that you use. So if you actually use the data model, you shouldn't have to worry about protobufs or any kind of file format. You should just be able to use the model. So there's actual model files built on top of this. But the protobufs kind of define a lot of what we do. So I think, let's see if I can find a good one here. Okay, great. So this is maybe not beautiful to look at, but let's go through this together. So one of the interesting things about IDRHA compared with other platforms like Fabric or Ethereum is that we have the concept of core transaction types. So instead of writing all the asset logic yourself to create a new asset and then manage balances for accounts, we have these core transaction types that are built into the ledger, and then so you don't have to write that asset logic yourself. So these types of commands are in commands proto, and you can look at this, and you can see that there's an asset, and asset maybe has some visibility associated with this. I'm not going to talk about this too much right now. Mainly, I think right now for the first version, everything is public, so we don't actually support these other two, but we will in the future. There's a create asset command. So this is nested under asset. So asset has a create message that you can make, and so assets look like this. So like something like this. So USD, this is SphereCake. So if you want to make like a USD asset, this is the asset name here, and then this is a domain name. This is the TLD, and then this is the subdomain in the TLD. And you can actually nest. I think we wanted to make it up to 5 levels deep. So these are just ways to uniquely identify the assets. So using something like internet domain names. So you have a name for the asset and then a domain. And then we don't use this optional data right now, but you can encode data into the asset. So maybe, like for example, if you're doing like car registration, you want to put car titles or land titles on a blockchain, what you would do is you would define like a unique serial number of the car, or maybe for land you would put like GPS coordinates or something in JSON data, and then put this inside data. And then this becomes an asset that holds this information that you can then give to other people, and it kind of manages what they own. So this is one of the things that we do. So you don't have to write smart contracts to create an asset. You just call create command, and you can define an asset yourself. I think, I'm not sure I like the name wallet, so that might change. But basically, accounts also can have assets. Is what this means. So actually, maybe it would help if I show you the data model. So this is actually open. So sorimitsu.atlassian.net. If you go here /wiki, you get our Confluence page, which is the IDRHA community space. And let's see if I can. Am I logged in? Okay, great. Let's see what they have here. For some reason, I think someone changed the links recently, so I can't find what I'm looking for. Here we are. Okay, great. I think
Yeah, I think this is open and not closed. So let me see if I can find my my diagram here. So there's different things about like product requirements here, quality attributes, REST API. There's really too many pages to keep track of all this stuff. So let's see, product requirements maybe. Someone deleted my folder. Okay, great. Okay, great. So this is the data model. So under Iteraha Core Objects, there's a data model. This is the data model. So one of the things about Iteraha is we support queries on the system. So we have what's called Ametsuchi, which is a database that we've created. So Ametsuchi is broken into two parts. One is a block store, which actually stores the physical blocks onto the hard disk, and the other is the world state view. So world state view is actually a Postgres database that you can do full SQL queries on. So this is the data model that is in Postgres. And you can see that you have an account, and accounts actually can have, all the accounts can be multi-sig accounts, so they have multiple signatories. So an account can have many account IDs and public keys, and then out of these you need a quorum. So the way you would use this is you could have 5 public keys associated with an account, and out of this the quorum could be, let's say, 3. That means that out of these 5 signatories, you need to have 3 that actually sign off on an account. And so that you can also have a status associated with the account too. I'm not sure what the vision is for status actually. Then accounts also are in a domain, so you have an account ID associated within a domain, and then you also have a bitmap kind of showing permissions. So accounts have permissions to do all these commands. So things like create asset or transfer asset can be controlled by a permission scheme, very similar to Unix. So you could have I don't know. So it gives you lots of flexibility. So you could have one administrator that can create assets, and then another administrator that, or another user that can only transfer assets, or things like that. So you can have different user classes into this. And the asset creator doesn't have to be the same person who can also add the asset. Like you could also have a group of people that can manage an asset together. So that's associated with a domain and an account. So an account has permissions on a domain, and also an account has permissions on an asset as well. So you create assets inside a domain, and then once you create the asset, you can have permissions on the asset itself. Peer is just peer-to-peer, or one of the servers. So it's just when you boot a server onto the network, you use your private key to boot it, and that's why it's associated with an account here. Let's see. So an account is, one of the interesting things about an account is the ID. So the ID is actually a text string. So this is like a username. So if you want to send someone an asset, instead of typing in, public key or some long address that doesn't make sense to anyone, you can actually type in the username and the domain. So something like I don't know. So let me see if I can find a good example in the wiki maybe, and data model, I guess. So our documentation is not the most beautiful in the world, but basically, let's see if I can bring up a terminal here. So basically, you could have something like I don't know, take miya I don't know, Soremitsu. So you could send me an asset by just typing in the username and then a domain. So going back to the data model, the ID is just a string, and then a domain is just a string, and there we have a special character @mark that separates the two. So you could say Takemiya at Soremitsu, or I don't know, like any kind of name. So it's just like a email address type of scheme. So it's actually very easy to deal with for humans. And I think that's one of the unique things about our project compared with something like Fabric or Ethereum, where you don't really have this type of robust scheme. And it's very different from Bitcoin too. We don't use a UTXO model. That doesn't mean you couldn't create a UTXO model somehow in this, but we don't really consider that right now. And eventually we also want to have the idea of atomic exchanges or atomic swaps for assets. This is useful for things like kind of like escrows in a way. So I want to give you like 500 USD assets in exchange for some other token, like 500 I don't know, 1,000 rubles, let's say. I don't know what the exchange rate is, but you would send it to me and I would send it to you, and then once we both sign off on the transaction, you would get an atomic swap. So that's one of the things that we're working on. So this is kind of a core to a lot of what we do, and then this is just translated into protobuf files like this, except one of the differences, of course, you have these actions like create or transfer, remove, like invite, like create an account, register an account, add a peer, remove a peer, different commands like this. So there's quite a lot of commands that are supported in the core part of the system. The idea is to create kind of a core way to represent all these, to represent any type of logic that you need using these core components. So you could build an application on top of this that then just works on these components itself. So if you look at our developers guide on the wiki, well, we have this kind of architecture that we're working on. Not all this is completely applicable, but basically the system looks like this. The only difference is for the version we're building right now, there's no chain code. That'll be a little bit later. So for the roadmap, we're working on version 0.95 with a release in mid-July. So actually in like 10 days is our goal. Hopefully we'll make it, but it'll be around then. And that will have all these components except for chain code, and then we'll work on adding chain code, because chain code is actually what we want to do is actually, I think, very unique. So we need to actually do some more prototyping in order to find the best solution. So I'll talk about how we want to do chain code in a little bit. But basically, we have an API in the front, which has gRPC and then these protobuf files that I was showing in schema. And then once you get a transaction, it goes to ordering service. You've got a peer service, business logic validation, consensus, and then the database Ametsuchi. So let's look at the transaction flow. So you get a transaction into the system. This comes from a client and goes to a peer. And all the connections with the peer pass through a system we call Tori. So Tori is, of course, Japanese, like Tori. Like this. It's a gate, right, to shrine. So everything passes through Tori and goes to peer. The first thing that peer does is it performs basic validation of the transaction schema, and then it checks the signatures to see if the transaction signatures are valid or not. And if these aren't valid, then you have to reject the transaction and log it to the error log. But if they are valid, then what you do is ignore the chain code for now. What you do is you send it to the the ordering service. It registers it into the queue, and then after a time limit, you create a block proposal. This is basically the way Ripple works, at least in my understanding. So Ripple waits, I think, 6 or 7 seconds, and then creates a block proposal every 6 or 7 seconds. If there's no transactions in the proposal, it doesn't create a proposal. So there has to be transactions in the queue. If there's no transactions in the queue, you don't create a block. So there are no empty blocks in Iroha. So this is ordering queue, create a block proposal. Then what you do is you send it to the consensus service, which is called Sumeragi. And then inside consensus, what each node has to do is it has to perform stateful validation. So stateful validation is validation on basically world state and comparing it, world state at the current block height and comparing it to the data in the proposal. So for each transaction in the proposal, first you check the permissions for whatever command is being created, or whatever command is being executed. Does the account have permissions to do it or not? So that's the first thing. And then you check business logic. So business logic is actually, well, to do both of these permissions and business logic, you have to go to Amitsuchi, which is our database, and you go to world state view. In the world state view, you just do the SQL query and you see, does this account have permissions? Business logic is things, it depends on the type of transaction. So if you're doing a transfer transaction, you have to see, do you have the money or not? So if I want to send 200 hryvnia and I've got 100 in my account, then that's an invalid transaction. So you have to have at least enough money to send. So these are business rules, and these are just programmed based on the core transaction type. And then if it passes validation, then you send it to your peers, and then you send it to the leader, and then the leader commits it. So I can talk more about consensus algorithm later if we have interest in time. What we want to do for chain code, this is just a proposal because we're still doing some research in it. But for version 1, we want to have chain code, and the way we want to do it is this. After you accept a transaction, you check the schema, you check the signatures, and then if it's a chain code transaction that's not executed yet, you send it to our chain code transaction generator. And chain code, as an input, it can use data in Amitsuchi, so block store or world state view. And as an output, you have a list of transactions using our core transaction types. So our core types, it's kind of like assembly in a way. They define all the basic operations that you can use in, I don't know, in your program or on the ledger. These are the basic operations that you can apply to the ledger. And chain code is a generator of these transactions. So what our current proposal is we set up a I don't know, sandboxed LXC, so Linux container. We use LXC. Inside of LXC, we run a C++ program that has a specific output, and the output is our transaction types, just a list of transactions. And these transactions are then fed back into well, they're not fed back to the client, they're fed back into the peer along with the chain code header. So it's kind of a special chain code transaction batch type. And then these are registered into the queue. So one chain code transaction can be a generator of other transactions. So you can only do this once. You can't output other chain code transactions inside a chain code transaction because that is kind of too hard to check if it can stop or not. So you can only do this once. But once you do it, then you have a list of transactions. And the cool thing about this is these transactions are just normal Iroha transactions. So they're still applicable to, or they're still controlled by the rules that we have in the system. So things like business logic and permission system. So it's much more robust than just treating the blockchain as a key value store. So in Fabric, the blockchain is really a key value store, and you can write to different parts kind of freely. You can do anything you want almost, and that's we think is kind of a bad thing. There should be some kind of constraints into the system. You should still be able to do everything you can do as long as you have permission to do it. so you can, like for example, if you want to create a smart currency that maybe every day you lose 10% of the value or something, you lose 10% of the currency. You could create a chain code, so contract in chain code, you add the chain code, and then execute this transaction once a day that will go through the code and look at the date maybe and remove part of your balance if it has permissions to do so. So your account has to you have to grant permissions to some account to execute the contract in order to give you or to realize something like smart money. So you can realize many different applications, but they're within a clearly defined framework, and it's really hard to it's much harder to make mistakes or to have a lot of security issues. That's kind of our philosophy in design. So we've anyway, so this is still at the prototype stage. So we're hoping to launch chain code September. So we'll see if we're successful or not. But it is an open source project, so we're open to other proposals. We're open to people working with us and looking at things. We did consider also, doing something like incorporating Hyperledger Burl, which is Ethereum virtual machine into this. There's a few things. We really hate parity. We were not a huge fan of the way Ethereum does smart contracts, and also it would break our permissioning model because there's no way to really integrate that. I mean, it'd be very, very hard. We'd have to write our own execution framework, basically. So that's kind of the overview of a transaction lifecycle in Iroha. So we're working on everything except for chain code as part of 0.95, and we're hoping within 2 weeks to get something that can be run nicely. So we have in the current master branch. We have some stubs. Not in master, sorry, develop. We have a lot of stubs for different parts. Everything is kind of organized under Iroha D. So Iroha D is, we also have a command line interface that we're working on, but the command line interface is actually kind of cool. It's not nearly being close to being done, but we want to make it so that you can generate key pairs just in the, so you type in Iroha CLI, and then you can generate key pairs, and then we want to be able to generate transactions and stuff, all just help developers maybe test different things. So that's in Iroha CLI. It's not close to being done, but we have Iroha D, which is the daemon, and this is kind of the main server application. And then there's Tori, which is the main part. There's peer service, ordering service, consensus, common, Ametsuchi, things related to validation are here. So stateful validation, stateless validation, validation of the blockchain. A lot of these are just stubs. So it's kind of easy to understand which ones are stubs and not, because we have the stub part. So what this is it doesn't really have this is the HPP anyway, but it doesn't really have logic written yet. So this is just some of these are just stubs to help with the architecture integrate together. So we're working on in the next sprint here to implement all these stubs. So we'd love to work with you if you're interested in helping out. So that's kind of the basic overview of a lot of, I think, the interesting parts of Iroha, at least according to, or at least relate to data model and permissioning, which are kind of, I think, very different from a lot of other systems. We've really put a lot of thought into this over the last year, and I think we've evolved the project quite a lot as from where it was even half a year ago. So I think we've been able to solve, I think, a lot of problems that we found doing some of the, or building some of the applications that we're building. So just some basic things. We use C++ 14. We make heavy use of templates and things like that. We typically use Google code style. There are some differences. Google code style, I think, recommends using .cc as the file name for C files. We prefer CPP, so we use .hpp and .cpp for file names. And there's one other difference that where we deviate from the Google code style, but hopefully that won't be confusing to anyone. So there's still a lot of work to be done, but I think we have pretty good architecture now, and I'm going to be trying to keep this wiki up to date, and also at soremitsu.atlassian.net you can see maybe some of these. If you can't see it, let me know. So there's things about core objects, like information about assets and what are assets, what are some of the things that are applicable, etc. So with that, I think I kind of want to make the discussion more interactive. Maybe people have lots of questions. So before that, I want to maybe kind of talk a little bit about the different platforms in Hyperledger and the use cases for using them. So let me go to hyperledger.org and let's take a look at some of the projects that we have. So you click on projects, and then there are 5 projects here. So I talked maybe briefly about these yesterday. So let's kind of go through these in order and maybe talk about what are the use cases where you would use each of these. So Hyperledger Sawtooth. The main differentiator here is they use a form of Nakamoto consensus called proof of elapsed time. They use Intel hardware, so special, I forget what it's called, secure computing enclave on the chip, to guarantee that you have to expend some time in your mining. So it's kind of like simulation of mining. You don't actually do lots of CPU calculations and use electricity. Instead, you just use some secure enclave on the chip to guarantee that you're spending some time. Because time is a finite resource, just like CPU power is. Really, proof of work is really just about time at the end of the day. So the advantage to this is there's no limit onto who can join the network. Well, except you have to have Intel CPUs. But to Intel, that's okay. But you can have thousands or tens of thousands, a million computers, a billion computers. Every device in the world can join your network and help to mine blocks. It doesn't matter. You don't have to know who they are. All you do is look at the proposal of the block the block that's created by the winner of this competition, and then it's just like mining, like in Bitcoin. So really, that's the use case for Hyperledger Sawtooth, where you have an unlimited amount of open computers and you don't want to control the network. Now, it is written in Python, so that's good and bad. I love Python. It's a beautiful language, but it's not really that fast. That being said, the typical Pythonic way of doing things is to write your code and then benchmark it, find out where the bottlenecks are, and then write those in C. Or Lua, and so maybe its performance is not such a big problem. IDRA. So I just explained our core asset model. So if you have any kind of just simple application dealing with the creation of point or monetary-like assets, then it's a really good use case, because you don't have to write the contract logic yourself. It's all in the core application. So I think that's the main use case right now. You could also say that maybe it's good for mobile apps or something, because we have crypto implemented in these different languages. Fabric. So Fabric is good if you want to really just treat the blockchain as a key value store and not have Byzantine fault tolerance. So basically, if you want Kafka, you should use Fabric. Fabric uses Kafka, of course, now for version 1. In version 0.6, they used practical Byzantine fault tolerance, but they kind of got rid of that, saying that companies don't really need Byzantine fault tolerance, because their companies. They already have contractual agreements together. Maybe they'll add something back in the future. Maybe they'll add it back in their private version of IBM blockchain when they're done with it. But Fabric is good if you just want kind of crash tolerance and treat a distributed ledger as a messaging queue, or messaging queue with I don't know, as a key value map. It also has some provisions for anonymity because it can block. It separates. Well. Okay, so I don't know if it's still in version 1 because version 1 keeps changing every week. But at least a few weeks ago, they had some provisions for anonymity. Oh, great. So my computer's not plugged in, so my... hopefully this will work. My computer's not plugged in, so occasionally the screen decides to go away. So they separated I don't know how to say. They separate the ordering of transactions and the endorsement. So the ordering is just ordering of a hash. It doesn't matter what the contents of the transaction is. The endorsement actually requires business rule validation, so stateful validation. So we're actually trying to do the same thing in IDRHA, but we haven't really finished this yet. But actually in our data model for a transaction, maybe I'll show it actually. Let's see here. So we have we kind of split headers and block bodies. So you've got the header in a block and you've got the body. So what you could do is the header only contains hash and signature. So and a timestamp. So what you can do is you can get rid of if you really wanted to create a new consensus algorithm that supported anonymity, you could have consensus or ordering be done only on the headers, and then some private parties could do validation of the business logic. That being said, we also have 2 people working on anonymous transactions in IDRHA. What that means is in Japanese, it's called Jundoke Ango. It's homomorphic encryption in English. So we have 2 people working on that. The Linux Foundation was nice enough to hire an intern for us to work full-time on this. And then we hired someone else to also help out the intern. So we've got 2 people working on just studying homomorphic encryption for IDRHA, and hopefully someday we'll have a fast solution. Actually, homomorphic encryption is very interesting, but it's a very broad field and it's very slow. And also, there's lots of problems about future-proofing. That being said, you can increase. So for things like, for example, oblivious transfer, you can increase the performance by restricting the domain that you're dealing with to only positive integers up to a certain size. So if you don't need big numbers or floating point or negative numbers, you can actually speed up the computation quite a lot. So that's one of the things we're looking at. Anyway, so I was talking about Fabric. So Fabric might or might not have some provision for anonymity. I'm not sure. Burrow, if you want Ethereum, you should use Burrow. I guess is the story. So Burrow is what used to be called, I think, Eris or something. Then they renamed it to Monex, and now it's called Burrow. So it's try to figure that out. But really, it's a fork of Ethereum in Go, more or less. It uses Tendermint consensus algorithm, and it seems reasonably good actually. So Monex works very hard on it. They're also a Hyperledger member. Indy, I don't know much about it. It's still coming soon, but it's written in Python, and it's mainly a platform to help with identity management. So that's what I've got to say. So if you want to deal with identity, maybe you could use Indy or some other platform. If you want to deal with Ethereum-style smart contracts, you should use Burl. If you want to have only crash tolerance and flexibility of doing anything, treating the blockchain as a key value chain, or key value store, then you should use Fabric. If you want to handle assets, point-based assets, you should use IDRHA. And if you want to handle a completely open system with a billion computers, you should use Sawtooth. I guess is the use case discussion. So with that, I'll make it interactive, and yeah, please ask some questions.
I'd like to ask about samples of business cases that you have covered by source code for Iroha currently available on GitHub.
Okay, so that's a good question. So what we have is very, very early code only. So we've got GitHub. Let me try to give me a second here. Maybe I'll use this page here. Okay, great. Okay, great. So, like for example, if you go to GitHub/Soramitsu, we have various like sample apps. This is the demo app here. This is just a simple point application, and it doesn't work with the current version of Iroha. It's very it's very early. But what we're going to do once we have a stable 0.95 release out is update this application to 0.95 version of Iroha, and then it'll be a good example of a simple point application. So well, I could try to demo the app, but maybe later. So this is basically a point type of application or digital currency, things like that. We need more samples and examples, and that will come, I think, once 0.95 is out. It doesn't really make sense to spend too much time documenting the version that's kind of in between states right now. So that's a terrible answer, but in short, we need more sample applications that are open. A lot of what we've done, unfortunately, is closed source as far as applications, but we try to keep the base layer completely open. So any other questions?
Nice shot, man. Tell how it became possible to start with so huge project, part of IBM team. You was like startup for your first step, or in a core team in first step. How it became possible to collaborate with so huge company?
Okay, so I think the question is how did a small startup like ours become a member of Hyperledger and create one of the key platforms? Yeah, that's a good question. So we joined Hyperledger last May, and we were originally looking mainly at Fabric to use as our platform, but unfortunately it didn't really meet all the needs or design philosophy that we had. So we created our own thing, and we open sourced it in September. And then in October, it was accepted. Well, we open sourced it in September and submitted it to the Hyperledger project. And this was actually the first real test of the governance model in Hyperledger. Because before this, you only had IBM, which created the project, and Intel, which is a huge company, and one of the sponsors in the project. So we're just kind of coming out of almost nowhere and proposing this platform. But what we did was, of course, before proposing it, we talked with IBM, we talked with Intel, we talked with a lot of the community members to kind of, find out how to position our project. Like we're not tackling the same problems that Fabric or Sawtooth are tackling. So we're focused on different applications. So it kind of fits a different niche. And also, I think one thing that helped is it's in C++, and which is a different language than the other projects, and it's a way to kind of bring C++ community members into Hyperledger was another one of the arguments I think that that was made, and so it kind of shows, or I think it speaks for itself that Hyperledger project is really well governed. So it's really about technology and not about corporate politics or influence. Because obviously, any of these main companies don't want other projects to join. I mean, from a company standpoint, but from an open source standpoint, or project standpoint, it's really something good. And actually, IBM is very serious about open source. I mean, there are some employees at IBM that really do believe in what they do and do a good job. Not everyone is that way, and there is a group of people who need to make money for the company. But overall, there are some really good people in the community. And Chris Ferris, who's on the technical steering committee of or the head of this technical steering committee right now of Hyperledger, is actually one of those guys. He's really big about kind of putting the technology in the project before maybe the marketing influence of the company. So any questions? If not, I've got some questions for you guys. Okay.
So as I understood, if I write a chain code in what you have proposed, and I need a loop something, and I may create 100 transactions, or maybe 1000, and then all of them should be added, and at some point that could be maybe a problem there.
Well, we want to limit the number of transactions in the block to 32,000 per block, just for mainly memory reasons. But maybe we can make that settable, I think. So yeah, if chain code runs for a long time and generates a billion transactions or something, obviously that's not really good for the system. So there needs to be limits on the time spent and also the number of transactions in the output. There's no concept in IDRHA of a native currency, so you can't do something like Ethereum and have gas. Rather, you just set limits that are reasonable. So there should be something like a rate limit for users on the system, and ideally that should be configurable because this is a closed network and people have to work in many different use cases in different environments. But we want to have good defaults for that. Yeah.
And I have another question. Would chain code be allowed to access external systems, like query some external server?
No, chain code won't have access to network, only to World State View and block store. So if you want to have external data, you have to put it into the local storage first. So as an example from our derivative contract project, we downloaded data from the Japanese meteorological agency, and then took that data, put it into JSON, and then wrote the JSON as transactions into the chain. And then you could query that inside chain code. And I'm being kicked off the stage, so. But yeah, there's quite a lot more I think we could discuss. But yeah, if you have questions, please talk to me afterwards. Thank you.
Раз. So guys, we're starting our panel discussion. Speakers, please take your places. We have only one microphone. Она не работает.
Гав. Надо просто включить. Может, он садится, единственное.
Okay, so let's begin. I'm really happy to see all of you in Odessa with great speakers from all over the world. Now we will discuss future of blockchain and future of cryptocurrencies as well, because we heard a lot of stuff about corporate technologies, about Hyperledger, but I guess most of all, some people who sit in here are really interested in things behind blockchain, like maybe Bitcoin, Ethereum, and this alternative economy as well. And I think speakers will present themselves better than me. So let's begin from Alex Yakovlev. From Amar, okay.
All right, thank you for the introduction. My name is Omar Sanchez, and I'm here representing Daimler from Germany.
Maybe your expertise square. So, which questions questions you most have most expertise? Sorry. Bitcoins, Ethereums, yeah, something. Do you invest in ICOs? You also may ask any questions after a small introduction from all speakers.
All right, so I started looking into blockchain, I think, back when the first paper came out. So really long time ago. I was a little bit too late for Bitcoin, to be honest. I missed the chance back in the good old days, yeah. But in terms of concrete experience, at Daimler, we are working on several projects using blockchain. And in fact, we just announced a project we jointly did with a bank called LBBW in Germany. The press release was last week, and it was a live transaction with a volume of 100 million euros. So if you have any questions regarding some challenges we see from our side, from a corporate side, I'll be more than glad to help. And if you have any questions on the concrete pilot we had, please feel free. Thanks.
Cool.
Hello, my name is Yuri Labintsov. I'm a co-founder of Syndicator. It is fintech startup. It is a combination of 10,000s of financial analysts' intelligence, of collective intelligence, and artificial intelligence. So this is the symbiosis that predicts future, makes analytics on financial markets, and this is the platform for traders with products that are used by traders to make trades. I have bitcoins and I use to pay bitcoins to our forecasters. So we are creating our own currency, which is also called syndicator, which is backed by mental impact of our forecasters. So they are making mental work, and we consider their intelligence and time and attention like a currency. So they are investing their own intelligence, and they are making an impact to the community, to the whole organism that we call hybrid intelligence. And based on their predictions, the whole system earns money, and that's how they bring the value, and that's how they get the value back. So we are paying them with cryptocurrencies.
Great. And what is your superpower?
Superpower, my personal superpower. I'm creating the super organism which predicts future. So my personal power, my background is from technological entrepreneurship. So I did lots of digital products, mostly mobile products and infrastructures around innovative projects.
I'm Alex Yakovlev. I've started mining in 2011. I win this chance. I'm working for Moscow Exchange, National Settlement Depository. We made several projects from e-proxy voting to management of ownership of commercial papers. And we continuously put a lot of interest in the area of distributed ledgers, and I'm also entrepreneur, making some projects like Block4Chain and few others using the same technology. And also I'm part of Hyperledger initiative, participating in few working groups.
Hello, I'm Dennis, and I have bitcoins. Sounds like a drugs addiction club. I'm working for DataArt. I'm responsible for our blockchain practice for different projects on different blockchains. And I really passionate about that technology and also opportunities which it gives to us.
I'm Makoto. I'm representing Sorimitsu. We're a Hyperledger member and we're based in Tokyo. I do have bitcoins. I used to be fairly active on Bitcoin Talk back in the day, but not recently. I became active in the Bitcoin community from 2013 when the first, in like January of 2013 during the first spikes. I bought some around $60 Bitcoin, but unfortunately only like 2 or 3. So anyway, we can't always predict the future. So I think my special ability is giving bad investment advice.
So, okay, I think the most important question for today is the future of cryptocurrencies, because corporates involving more in blockchain technology, trying to develop something to cut their costs on private armies using blockchain. It's normal, I think. What is the future of this alternative economic on your point? Who wants to start answering this question? Okay, Alex.
Actually, my vision is a kind of dreamer to make crypto economics available for normal economics. We are working on services for custody and for depository of crypto assets, and we are trying to be a little bit agnostic on these assets, not only Bitcoins, not only cryptocurrencies, but all types of assets that can be managed by distributed ledger. And I think that this type of economics will rise and rise more, like in 10 times each year. And we will see a lot of new features and new types of usage of these crypto assets recently.
Okay, anybody else?
I see that usage of cryptocurrencies will grow from inside of this new economy, from inside of this community. So it grows in people's mind, and people exchange their services, products, and values inside this economy, bringing the new values to this infrastructure, to this community, and they pay each other with cryptocurrencies, with different types of currencies for different types of values of different types of services. So this is my vision. My vision of this way is based on the way how we create our currency and how we pay for new type of mental work. So we have a special currency that is paid for analytics and for predictions, and it has a value. So I see that there are rising new companies that are providing services in this sphere of cryptocurrency, in consulting for blockchains, and they get paid with cryptocurrencies. So this is the boiling soup that is growing from inside.
Okay.
In my opinion, one of the big hurdles we have at the moment is the volatility of cryptocurrencies. So from a corporate point of view, in order to be able to use it, you need a certain stability, also in terms of the actual value of the currency. So it might not be absolutely necessary to have an officially regulated legal tender as a cryptocurrency, but you need to be able to at least plan with a relatively stable value over a period of time. At the moment, of course, because of the hype, there's a lot going on, a lot of new ICOs, and also the value of certain coins is going up and down a lot. So I feel like after a certain phase of consolidation, we will reach a point where you have a certain stability, and this will be a great advantage, I think.
Alex, you have something to say?
Yeah, actually, I'd like to ask if we will have a stable coin ICO, will Daimler sponsor it?
I can't comment on that.
Oh, okay. So, guys, if someone wants to ask any questions, you may just raise your hand. And no questions, Roman. Okay. Не пригодится.
Why Google not active on this area? Maybe it think that is huge bubble, hype, and what do you think about it?
Interesting question.
Google have invest in only one blockchain-based project.
That's public investments. But are you sure that they are not involved into researches? And,
no, I am not sure, and I want to hear.
So I'm not deeply involved in Google politics and what they do internally, but I think that they do not do that publicly because this is not their business. This is not their value proposition that they used to say. That is not connected to their mission statement, which is about the global brain. But I'm sure that those great minds that are working in Google, they are connected with blockchain and they are working with it. It's just we're not on that stage where they can say it publicly. I think that.
Yeah, also probably we shouldn't just be aware about Google, yeah, because another big players like Microsoft, IBM, and another big and great corporation involved into the different communities and into blockchain experiments. Probably Google just decide to be not try to reinvent here the wheel, and they already have so many different interesting projects in which they could spend their money and their thoughts. Yes, so probably just not their piece of cake, something like that. Any
Anybody
other
else?
questions? Sorry?
No. Okay. No questions, no answers. So, one question.
Yeah, I have one question from my guy. He asked me to ask you, what is advantage of structured and developed economy currency user to switch to crypto?
Who?
What do we mean by structured? Yeah, because I don't think any economy in the world really structured.
No, I think it means to switch from the economy to the crypto. What is the advantage to switch?
You meaning from fiat currency, something
Yeah.
like that? It could be just a decision, based on different things around. Yeah, so I don't think really big communities right now could switch into cryptocurrencies without any problems. Yeah, but we already also see how, for example, Bitcoin started from fully illegal cryptocurrency. Right now, you could just have a credit card and pay with USD or euros around the world without any problems based on your Bitcoin wallets. Yeah, so I think it will be step-by-step evolutions. And also why someone could want to start working with that, because it probably provide a little bit more anonymous time to time. It's not could not be blocked by some government, but again, as soon as you try to do something legal or illegal, it should not be the case.
Thank you.
So I have an opinion on it, but yeah, I think once central banks start to issue centrally banked digital currencies that you can just use like in a mobile app in daily life, I think it'll be much harder to convince people to use some other currency that maybe is not stable, maybe has no recourse if you lose your private keys, for instance. So it's, but maybe that's okay because the current use case for cryptocurrencies is not payments. It's obviously not payments. The current use case for cryptocurrencies is obviously speculation. And if you don't believe me, go to Bitcoin Talk or CoinMarketCap, or any kind of exchange or something. So people really are having a lot of fun and doing lots of new and interesting ideas, but it's all because of speculation. So it's kind of like finding a new scheme. It's a new Wild West. Everyone's trying to make money and make new things, but maybe you get some innovation too. Maybe you create like a steam-powered car or something like that. So we saw this type of innovation back in America when people moved into the West from the East Coast and were exploring a new land. And that's kind of what we're doing now in the digital domain. We're exploring a new financial frontier, but we're obviously not creating a payment system, is my personal opinion. I mean, using cryptocurrencies. It's going to be the central banks, it's going to be centralized governments, or even the UN, who are going to come and create digital currencies that people are going to use. And we won't call them cryptocurrencies because they're not going to be maybe made by anonymous people, but they'll act much the same way. There'll be rules of the system that everyone knows and understands, and that from that we'll have higher trust than maybe even physical paper money.
Okay.
Price prediction.
For Bitcoin? Okay, so I absolutely am the worst trader in the world. I think it's my personal opinion that around this fall, Japanese, so the top 5 FX companies in Japan all created child companies to trade cryptocurrencies, mainly Bitcoin and maybe Ethereum, we don't know. But these currencies will get licensed and come online about maybe October is my guess. And so we might see some increase in price, maybe even like bubble dynamics where it could peak to maybe 10,000, 12,000 per Bitcoin. in US dollars, but then I think it'll crash down to under 2,000 is my prediction.
Okay, someone else maybe want to ask any question? Okay, so I have another topic to discuss. It's first of all not about ICOs. We all know that ICOs from Pavel Kravchenko speech. We know that ICOs it's like a Ponzi scheme, but we will discuss it later. Why do you think blockchain become the universal super or magic thing to solve any problem for now in this hype situation?
I have one opinion, and that's because what the technology kind of has mysterious roots from Satoshi Nakamoto. This mysterious, well, everything's falling down. This mysterious Japanese guy, and but the cool thing is, despite all these hacks and all these problems, it's proven very resilient. So the technology continues to run. Bitcoin, hasn't really stopped. I mean, it's been DOSed many times, but I think because of that, people have so many IT problems with related to DDoS attacks, security problems. People kind of see this, look at the system and see, oh, it's never been hacked. It keeps running, so maybe it's something that we need. I think that's one of the key components.
Yeah, also probably we should not name like a blockchain thing which will save our world. Yeah, so this is just a technology, and we have to try to adopt it on the some cases, and also probably not to adopt it in other cases. And that's the thing. Yeah, the biggest problem which I personally think in the community right now is probably we try to use blockchain everywhere for everything, and as soon as it's not working, we could say, oh, it's a bad technology, let's stop it, not do it in future, something like that. And that's also could be a big problem to the community.
Okay, Amar.
Stop trying, yeah, because we could try to produce some good products, we could try to produce some bad products, and for example, I really like ICO, yeah, so I don't think it's as a Ponzi scheme. But also, as soon as we try to create like a 1,000 ICO, we should understand successful would be 1% or probably 0.5%.
I think that's the key point. I think there's a huge complexity behind the topic. It's not so easy to understand. And so because of the complexity, people see it as a kind of wild card. I mean, it's so complex, it's so new, it's so flashy, it's going to solve all of my problems. It's kind of like we experience a very high expectation in regards of artificial intelligence at the moment too. And it's also a topic where you get a certain idea, and bridging your initial thought with the reality is very challenging. So really getting the deep understanding to say, okay, this is the limitation, this is the right use case, this is actually something I should do with it. It's just going to take some time, I think, for everyone. So I think at the moment we're in the middle of the learning process. And after a while, we will see the real use cases that stay and the others will disappear.
So my answer that blockchain will not change, not solve every problem. It will solve some problem, and it will create new problems.
And, what is the best use cases for blockchain? How do you think?
There are lots of, and I think that payments are also good use case. And actually, for in my personal practice, I had the experience, the advantage of payments using blockchain. So I did. It was much easier for me to pay globally to people from all over the countries with Bitcoin rather than with USD dollars. It was easier to automate this process. So for me, this is payments is one of the use cases. But I'm answering to the previous question that about problems and why. And I think the reason is I think that everything will be changed, and reality is changed by ideas. And what is great here is the ideology behind that technology. And this ideology is what will change everything, and is changing right now. And for me, what inspired me personally is the way how the money is created, the mechanism of emission. This is the key, the root of everything. And this, I think, I see that this is the root of ideology of new economic.
Ok. Alex, maybe you want to add something?
Actually, I have nothing to add, almost. Just one thing. If you see the person saying that Bitcoin is good and the price will be higher, just ask him how much Bitcoins do he have.
Sure.
In most of all cases, he just has Bitcoins and he has it right somehow, and he just want to have a higher price. It's easy and it is common.
Looking for buyers. About what? Sorry. Just
Hard fork. It's a keyword. Hard fork. I just propose to talk.
Okay, I think we have a Bitcoin hard fork proposal here. То есть вы конкретизируете вопрос, что вы хотите под хардфорком? Окей.
Actually, unfortunately, it is a little bit out of Hyperledger initiative because we have nothing about hard forks inside Hyperledger.
Yes, but you just need the time. Okay, maybe some of our speakers have any expectations about possible Bitcoin or Ethereum hard fork. So you mean that, yeah? Okay, but Hyperledger, I don't know about plans inside Hyperledger to hard fork Ethereum or Bitcoin. Maybe maybe we should think about it.
Yeah, actually, we will address this question to architecture working group. Do we need hard forks and do we need something new like soft forks or something pluggable?
But I think in this case, it would be great to speak about consensus. First of all, social consensus in cryptocurrency community, and consensus maybe in this underlayer of corporate community in blockchain industry. If we all see that it's really very hard to find consensus in Bitcoin. All we know about this block size debate, which proceeds for this 2 years, I think, or 3 years. It was. What about consensus in a corporate layer of blockchain industry? Do this layer need any consensus, or it's just semi-centralized or totally centralized systems? Because ideologically, corporate stuff very different from crypto anarchism, etc.
I think it really depends on the use case. So if you're talking about blockchain within one organization, you don't have a trust issue, right? So in this case, sure, you could have a centralized system. At the same time, you have to ask yourself the question, what is the added value of using a blockchain? In that case, there could be some, but it's not there by default. So kind of a difficult topic. On the other hand, if you are interacting with third parties, you do have the trust issue. And what we experienced was going for a proof of work might not be the best solution for some cases. And because if you're talking about a purely B2B environment, you can really talk about other mechanisms that might suit your case a little bit more. Because just running calculations in the background, you're decreasing the efficiency of the system by consuming a huge amount of energy that is just not necessary in that case.
So let's just imagine the big corporate blockchain distributed between 100 counterparties, and the situation when they need to implement some improvements. The system works well, for example, kind of Bitcoin block size debate, but on another layer. You know what I mean? Understand? Yes. So can we imagine this and how this problem could be solved in future?
I think it's a very theoretical discussion at the moment because, to my knowledge, there is no such industry setup as of today, and so guessing the priorities and the interests of the different parties at this point is very hard.
Actually, I'd like to add that in corporate environments, it's always not so easy to have such decisions. We need to form a group to discuss and provide few workshops and maybe make a new version of standard. And it can take up to 10 years to change the corporate blockchain rules. And it is understandable and it is distinguishable. But at this moment, we are trying to make a kind of first steps of standardization. So now we don't need to have such huge process because we have nothing working in corporate world like running 24 hours. And this is our chance because when it will run, it will be much more harder to change anything. And because of this, we spend a lot of time in discussions on ISO, on each events, on how it can work and how we can make it stable.
Yeah, and also probably it's not so new problem. Yeah, it's the same problems with each technology, with each standard which you just introduced. And for example, Swift have their own standards for more than few thousand of banks. Yeah, so how they solve the problem when they want to add some filter to them? It just has few workshops, few debates, and other stuff will be the same. Again, blockchain probably it's just great new technology, but it's not produce some new problems or new solutions. Yeah, it's usually just a new shape of the possible problem solving and another stuff around that.
Well, at least for financial use cases, it's still at least for financial use cases, it's still going to be limited by regulation. So typically, if you're a financial institution, you have to get systems approved by FSA in Japan. So it's going to be very hard to upgrade once you get approved. And it's also going to be hard to move from traditional databases to blockchain technology. So even in corporations, there's always some bureaucrats somewhere who are kind of controlling the rules of what can and can't be done. So it's not just technologists running everything.
Okay, I think we need to finish because it's already 5 p.m. So if anyone have questions, it will be final questions, and we'll close it. So okay, no questions. So thank you. Sure.
Thank you all for taking part. So these few days were really interesting for us because mostly DataArt like
here in Odessa, we work with programmers and things like that, and business questions like this are rarely discussed in this conference room. So it was a really cool thing to host for us. And we would like to thank you all. Programmers have like a real little legend, so to say, or a joke. When they have a problem with code, they need to talk to a rubber duck. Because when you explain your code problem to a rubber duck in the way that it understands, you're able to look at the problem from another angle and solve it faster. So guys, we wish you to never have any problems and hope that rubber ducks can help you on the way.
Thank you so much.
I think it deserves a round of applause. Oh, we missed one. Okay. I hope that you will gladly cooperate with us in the future, and I wish you great stay in Odessa from those who are not from here. And thank you all. I think our Hackfest is over. Thank you.
Thank you so much.